Welcome everyone. Myself Shriya from Sri Venkateshwara College of Engineering from CSE Data Science Department. Today I'll be giving a presentation on the topic of distribution models in NoSQL from the subject NoSQL itself. So first, let's dive into the topic. What are distribution models in NoSQL? In NoSQL databases, the distribution models refers to how data is stored, how they are managed and accessed across multiple nodes in a distributed system. These models are designed to handle a large-scale data with high availability and scalability. Here are the main distribution models in NoSQL databases. Let's look into them one by one. The first topic is sharding, or also known as horizontal partitioning. Definition: the data is partitioned across multiple nodes, with each node holding a subset of the data. Let's look how it works. Each record is assigned to a specific shard, which is based on a sharding key. Example, a hash or a range based. Different shards are stored on different nodes. The advantages of this method is it increases the write and storage scalability. Each shard can be queried independently, reducing the load on any single node. The challenges faced by horizontal partitioning are it requires a proper sharding strategy to avoid the hotspot or unbalanced shards. Complexities in query execution when data spans multiple shards. Example are MongoDB and Cassandra. The second form is replication. The definition is the data is copied and stored on multiple nodes to ensure the redundancy and high availability. The types of replication is master-slave replication. Here one node, which is the master, it handles the writes. The replicas, also known as the slave, they handle the reads. Next is peer-to-peer or multi-master replication. All the nodes can handle both the read and write function with eventual consistency. The advantages of replication is it provides fault tolerance. If one node fails, the another can replica the served data. It improves the read performed by distributing a read request across replicas. The challenges faced by replication is managing the consistency between replicas, especially in peer-to-peer replication. The risk of stale reads in eventually consistent system. The example is Couchbase or React. Third model is consistent hashing. Consistent hashing, the definition is it is a specific method of sharding where data is distributed across nodes, which is based on hash function. Let's see how it works. Data keys are mapped to points on a hash ring. Each node is responsible for data within a specific range of hash value. Adding or removing nodes minimally affects the distribution of data. The advantage is it handles node additions, removals gracefully without significant data reallocation. It provides balanced distribution and avoids hotspots. The challenges faced are it requires careful hash function, which is designed to ensure even distribution. The example is DynamoDB or Cassandra. Strategies are hash-based partitioning. The data is distributed based on the hash of a key, ensures even distribution but may cause issues in range queries. Next is range-based partitioning. The data is divided into ranges based on the key values, efficient for range queries but may lead to uneven load distribution. The third is geospatial partitioning. The data is partitioned based on the geographic regions, useful for applications with location-based data. Hash-based partitioning. Let's look into the hybrid models. Definition: it combines both sharding and replication to achieve a scalability and fault tolerance. How it works: the data is first shared across the nodes, and each shared is replicated. It balances the scalability and redundancy. The example is MongoDB, which replica sets with sharding. The factors influencing the distribution model choices, the data size and growth. For large-scale data sets, the sharding is crucial. Read versus write patterns. Replication improves read-write performance, while sharding aids write scalability. The third point is fault tolerance requirements. Replication is essential for high availability. Consistency versus availability. It is based on the CAP theorem. Different models trade between these two, and redundancy. Again, the example is MongoDB. Look into the advantages. The first advantage is horizontal scaling. The distribution models such as threading enable the addition of more nodes to the system, distributing data and workloads seamlessly. The second advantage is elastic scaling. Resources can be scaled up or down based on the demand, improving the cost efficiency. The second advantage is high availability and fault tolerance. Replication ensures that multiple copies of the data are stored on different nodes. So if one node fails, the another can replica and serve the request. Uh, Geographical distribution data can be replicated across regions for disaster recovery and to improve the latency for global users. The third advantage is the improved performance. Load balancing by distributing data across nodes, read and write operations are handled in parallel, reducing the bottlenecks and improving the throughput. The localized query sharding allows specific queries to be directed and to the relevant shard, reducing the unnecessary data scans. That's all with my presentation. Do like, share, and subscribe.